Hey, thanks for joining me for this Firecast. My name is Jen Person, and today I'm going to use Cloud Functions for Firebase to help make my app more family-friendly by automatically moderating the content that people add to it. If you're just starting with Cloud Functions, you should watch this other video first to get set up. Then come back here to follow along. So I have this app that lets people post messages to a discussion group, and to make it more suitable for families, I need to make sure messages are okay by removing inappropriate content. I don't want to duplicate all the same logic in my Android, iOS, and web apps. I'd rather have it all in one place, and I'd like to be able to update it without having to publish new apps to all my users. I can solve this problem with Cloud Functions for Firebase by writing a function in JavaScript that triggers whenever a new post is added to my real-time database. That function will run in Google's Cloud and not inside the app itself. What I want to do in that function is look at the contents of a new post, make changes if necessary, and write the updated post back into the database. The way my app works is like this. It uses Firebase Realtime database to push an object containing the details of a post under /posts. So what I can do is configure my function to respond to the data written at that location. Here's what that looks like. I'll go to the Functions folder for my project, which I already created with the Firebase command line, and I'll start VS Code here to edit the index.js file. I'll define and export a new function called sanitizePost, then specify the event I want to trigger on. This one is a database trigger, and it's looking at the path /posts. It's also using wildcard in curly braces to match the push ID of the post in that path. I'm interested in write events, so I'm going to use the onWrite method, which receives an event object that describes what changed. To fill in the body of this function, we need to understand the event that gets delivered here. An event object has a bunch of properties, but there are two in particular that are the most interesting. The params property contains an object with key value pairs of all the wildcards from this path. In this case, params will have an entry for the push ID that was generated by the client SDK. The event's data property contains an object with a description of everything that changed when the write happened. There's a lot of things in it, so I'll only talk about the most important ones. The type of this object is a delta snapshot, and it's similar to a regular database snapshot you're already been using to read data out of your real-time database. It has a property called key, which is the name of the location where the write happened. In this case, it's the push ID. There are also properties called ref and admin ref. These are database reference objects, just like the ones you already know. There are methods you can call in the delta snapshot as well. You have a few for navigating and iterating the data at the location of the change, but the one you'll use the most is called val. This returns all the data inside the delta snapshot as a JavaScript object. For example, if I call val on the delta snapshot for my function that sanitizes new posts, it will look something like this, expressed as JSON. So, I need to write some code to reach into those title and body strings to make sure they're safe for families. So I'll write that now. Inside my function, the first thing I'll do is use val to get that JavaScript object with the post data. Then I'll call a function called sanitize that takes a string and returns a modified string, overwriting the previous value in the object. And finally, I'll write the post back to the location where it came from. I'll also paste in a sanitize function here that changes the word stupid to the word wonderful. Of course, this should be more sophisticated when doing this for real, but you get the idea. And that's the main logic of the function. Pretty easy, right? But we're not done yet. There are two very important parts to this function that are missing. First of all, we don't want this function to return before the write back to the database is complete. It turns out that the set method is asynchronous, meaning it returns right away, while the write happens in the background. However, it returns an object called a promise, which is used to track the completion of that write. Cloud Functions can use this promise to wait until the work is complete. Without this promise, there is a risk that the write may not fully complete, and you'll lose your data. You can use it like this. All I need to do here is return this promise from my function, and we can be sure that it'll wait for the write to complete. In the sample code we provide on GitHub, we usually just return the promise directly, like this. Learning how to use promises effectively is a really important part of programming with Cloud Functions. I'll say a lot more about this in the next episode, but for today, it's enough to know that returning the promise from the set method is the right thing to do. There's still one other subtle problem with this function. Remember that it triggers any time a post is written to the database, and that includes the update that happens right here in the function. So, what do you think will happen if I trigger it once by writing a post in my app? it'll run, make changes to the post, and then write it, which then triggers the function again, which then writes the post to the database again, and so on. That's right, it's an infinite loop. And of course, that's very bad because you could exhaust your functions quota or pay way too much money. So how do we prevent that? Well, there are several ways you can do this, but the critical task is making sure that when the function triggers a second time after the sanitized values are written, you have a way to determine if the function should stop without writing the data again. For my function, that means I need a way to determine if the text is already sanitized. An easy way to do this is with a flag that I'll set when I write the post back to the database. What I'll do here is add a Boolean property into the record for the post. Then, the next time the function triggers, I'll check to see if that's set and simply quit before writing again. While I'm here, I'll also log some stuff to see in the console later. Console.log works just like it does if you were writing JavaScript for a web app in a browser. Now, I think this function is ready to go. I'll run Firebase deploy at the command line to send this code to the Google Cloud. Then, I'll switch over to the database console and manually add a post. I've already got one here ready to go. I'm going to click the add button and pay close attention here because the data is going to get updated quickly when the function triggers in response. Sweet! Now, I'll switch to the functions console and choose to view the logs for my function. And you can see here the stuff it logged. You'll probably want to log a fair amount as you're learning and experimenting with cloud functions. So now I have a simple function that sanitizes posts as they get updated in the database. Your functions could get a lot more complicated, so be sure to read the documentation to learn all about the things that you can do with the database trigger. And also, take a look at the sample code on GitHub as well. The links are in the description below. And be sure to subscribe right here to the Firebase channel on YouTube to get notified of new Firecasts about cloud functions and other Firebase features. I'll see you next time.